always have to look at the diagram or the graph of two straight lines in order to determine whether they are parallel or not. Is it possible by observing the equation of straight lines to decide whether they are parallel or perpendicular to each other? It is possible. There are certain traits of lines which are parallel to each other. That is the equation of lines which are parallel to each other and perpendicular to each other. Let's look at that in this topic. Equation of lines parallel and perpendicular to a given line. So simply speaking, the equation of a line which is parallel to the given line ax plus by plus c is equal to 0 will be of the form ax plus by plus lambda is equal to 0, where lambda is another constant but not c. Because if it is equal to c, then we'll be talking about the same straight line. So of course, the same straight line, you could argue that it is parallel to itself. But then if the constant part is different, then we are talking about a different line which is parallel to the line ax plus by plus c equals 0. How do we know this? Well, ax plus by plus c equals 0. If we put it in the slope-intercept form, we get minus a by bx minus c upon b. And similarly, the second straight line, if we put it in the slope-intercept form, we get y equals minus a by bx minus lambda by b. And so comparing the slopes, that is, the slope of the first line is minus a by b and m2 is equal to minus a by the slopes of the two lines, we observe that they are both equal to the same quantity minus a by b, and thus always the equations of the lines which are parallel to each other will have the same x and y coefficients. Always it will be of the form ax plus by plus one constant equals 0, ax plus by plus another constant equals 0. Always will represent a pair of lines which do not intersect each other on that plane. So therefore, actual examples could be of the type x plus y minus 7 equals 0, y is equal to minus x plus 4. So of course you could rearrange the second equation and bring it in the form of x plus y minus 4 equals 0. Here the coefficient of x in both equations is 1, and so is the coefficient of y if you write them both in the general form. So this is the important thing. If we write both the equations in the general form of the equation of a straight line, and in that form the x and y coordinates, the x and y coefficients of the two straight lines are same, then if the constant terms are different, then we can conclude that the two lines are parallel to each other. Next, the equation of a line perpendicular to the given line ax plus by plus c equals 0 is bx minus ay plus lambda equals 0, again where lambda is an arbitrary constant. So here lambda may or may not be equal to c. Most of the times it's not equal to c, but it's okay if it is equal to c as well. So this is how we identify whether two lines are parallel or perpendicular to each other. Here, if we write the first equation in the slope-intercept form, we again get minus a by b x minus c by b, and the second equation is y equals b by a x plus lambda by a. So the slope of the first line is minus a upon b, slope of the second line is b by a, and thus the product of slopes equals minus a by b times b by a, and so that's equal to minus 1. The product of two lines which are perpendicular to each other is equal to minus 1, and thus we get that the product of slopes of these two lines is equal to minus 1, meaning that they are perpendicular. And thus we can conclude that the equations of two straight lines which are perpendicular to each other will be of the form ax plus by plus c equals 0 and bx minus ay plus lambda equals 0. That is, interchange the coefficients and put minus sign on one of them. So therefore, actual examples would be of form 3x minus 2y plus 1 equals 0, and 2x plus 3y plus 5 equals 0. So as you can see here, the slope of the first line is 3 by 2 and the slope of the second line is minus 2 by 3. And thus these two lines can be said to be perpendicular to each other.